Let's go a little deeper and try to understand various types of fact tables also. The one that I have defined, that is actually the fact table which is used the most, but if needed there can be other types of fact tables also. The first one is transactional fact tables, and the grain is at individual transaction level. And when I say transaction, it is not monetary, it can be anything else. In our case, the transaction was order, and the fact table that I mentioned earlier is a transactional fact table. And as I said, that most cases, in 90-95% of the cases, you'll be using transactional fact tables only. But there can be requirement wherein you have to have different fact tables also. So that's where periodic snapshot facts is another type of fact table. What it does is, it is an extended version of the transactional fact table, and it captures summary over a period or over a time period. So if you think about the previous example, when I was talking about the second requirement, I could have created the grain at individual order level. I did not do it because I had already defined a grain which was at lower level. But if absolutely needed, you could have created a different fact table with a different grain. In periodic snapshot fact, we define the time period beforehand, and then we take a snapshot, run some transformation, and then load the periodic snapshot table on a daily basis, weekly basis, or monthly intervals. So these are the time periods or predefined time periods that you want the snapshot fact table to be created or data to be loaded at. And you might have guessed that the grain would be at the period level. Now imagine that we define the grain in such a way that it captures a periodic snapshot fact. So unknowingly we do that. Now, if you have to find further information, if you have to drill down further, it becomes really challenging later on, because we have defined the grain at individual time period level with unknowingly. And if we have to create a more granular grain, we'll have to load the entire fact table from beginning, because here we have lost the data because we have aggregated. Define another grain at lower level. Then you have another fact table, accumulating snapshot fact table. So what it does is that it contains accumulated data over a period of time. When I say accumulated, it means that aggregated data from beginning till the date when the snapshot is stored or when the snapshot is created. So let's say I create a snapshot on a weekly basis, and let's say I start today. The first accumulating snapshot would contain the data from today to the next 7 days. Next one would contain from today to the next 14 days. The third one would contain from today to the next 21 days. So that's what accumulating snapshot fact tables are. We have also something called confirming facts, but for that I'll have to tell you confirming dimensions or confirmed dimensions. So these are dimension tables that are used across multiple star schemas. Now the question is, can we have multiple star schemas? The answer is definitely yes, because you might be having different business processes in your organization. And for each business process, you might have a different data warehousing system. And we also call it as data marts. So confirmed dimensions are the dimensions which are used across multiple data marts, because each data mart would have its own star schema, because those are a scaled down version of your data warehouse. So what are confirmed facts then? Confirming facts are those who use confirmed dimension tables, or if there are multiple fact tables in a single star schema. That is also possible. We can create multiple fact tables in a single star schema. Those would also be known as confirmed facts. Then we have a few other types of fact tables like additive facts. So in additive facts, the attributes or the quantifiable attributes can be summed across all dimensions. For example, price and quantity. So if you look at our star schema that we had created, we can actually add the price across all the dimensions, meaning we can do a select sum price, comma order ID, group by order ID. Then we can do it for product level, we can do it at customer level, we can do it at seller ID level, date level, and payment ID level. And we can do it across all of them together also. So that's why price is an additive fact attribute. Then we have semi-additive facts, which can be summed across only a few dimensions. In our example, I have not mentioned any semi-additive facts, but let's say there's order per day for each item. We can add these only on a per day basis. We cannot add this across, let's say, customer basis and day and by individual days. So those would be semi-additive facts. Then you have non-additive facts, which cannot be summed at all. What I mean by that, even if we sum them, it would not make any sense. For example, discount. Now again, if I go back to the star schema that we had created, now let's say I add discount across order IDs or across product IDs or across customer IDs. So let's say for one product the discount is 10% and for another product the discount is 5%. And if we add them, then it would be 15%. So it does not make any business sense to add the discounts, right? Even though it is a quantifiable attribute or a quantifiable data. So that's what non-additive facts are, when you cannot sum the quantifiable attributes across any dimensions. Just like fact tables, we have different dimension tables also, and we call it as slowly changing dimensions. Now, why slowly changing dimensions? Because you might have seen that the dimension tables are mostly static. Even if they change, the change does not happen that frequently. Maybe one change in a few months or maybe few years also. That's why these are called slowly changing dimensions. And the first dimension table, the dimension tables that I have created, that is called SCD0, wherein we have descriptive information about the business entities, for example, customer. Now let's say the customer wants to change address. How often that happens? Maybe once in 3-4 years. So you can imagine that the changes are very slow. That's why it is called slowly changing dimensions. So the first one is SCD1, or slowly changing dimension 1. So in this case, what happens? We override the old data with new data, or override the old attribute value with current value, and the attribute contains the recent value always. For example, let's say the first customer, Vikas, changes the address from Bangalore to Mumbai, and the change happens on 1st January 2025. So SCD1 would contain only one table, wherein BLR would be updated to MUM, which is Mumbai, and effective date would be updated from 1st January 2010 to 1st January 2025. This is what SCD1 is. As you can see, there's no history maintained. So if we use this, we'll never know where Vikas lived before 1st January 2025. And that problem is solved by SCD2, which adds a new row whenever there's a change. And it helps us to track the historical data of all the changes. So it would be like this. So we'll add a new row, and in this new row would have all the values as it is except for address and effective date. So the address has been changed from Bangalore to Mumbai, and the effective date has been changed from 1st January 2010 to 1st January 25. So we have a historical information of all the changes, and this is called SCD2. And this is used a lot in data warehousing systems. Both SCD1 and SCD2 are used a lot. Finally, we have SCD3, which is a little tedious. What it does is that it adds a new column with the changed value. Now again, it would be like this. So we'll have two columns now, prior one address and current address, and prior one effective date and current effective date. So if the customer changes address again, then we'll have to add two more columns with prior to address and prior to effective date. So as I said, this is tedious and cumbersome. So that's why SCD1 and SCD2 are used the most.